In Lesson 3-4, we will be discussing exponential and logarithmic equations. In video 3.4.8, our learning target is for students to check logarithmic equations for extraneous solutions. In example 8, we are going to check for extraneous solutions when we solve the logarithmic equation log of 3x minus 4 is equal to 1 plus log of 2x plus 3. Now, anytime you're solving a logarithmic equation, you want to try to get a single logarithm on both sides. In this example, you have a logarithm on both sides, but we also have this additional plus 1 in front of our logarithm, which in this case, if you cannot just get a single logarithm on both sides of the equation, then I would like you to pull both logarithms on the same side of the equation, and then rewrite the equation in exponential form. So what I'm going to do is I'm going to take this log of 2x plus 3 and move it to the other side. So what I am going to do to move that to the other side is I'm going to subtract log of 2x plus 3. And I'm still going to be left with 1 on the right side of our equation. So this logarithm stays put. I would subtract log of 2x plus 3 on both sides, and then I can use my properties of logarithms to combine these two logarithms into a single logarithm. So when we subtract two logarithms with the same base, we're using the quotient rule, and I would get log of 3x minus 4 divided by 2x plus 3. And that's all equal to 1. Now that I have my equation in a single logarithm format, we only have a single log here, I'm going to rewrite this logarithmic equation in exponential form. So our logarithm here does not have a subscript number, so we know our base is 10. So we would say 10 to the first power is equal to 3x minus 4 over 2x plus 3. Now 10 to the first is equal to 10. So I would get 10 equals 3x minus 4 divided by 2x plus 3. I'm going to continue solving this equation on the next slide. So with the equation 10 equals 3x minus 4 divided by 2x plus 3, I could make this into a proportion by putting a 1 underneath the 10. 10 divided by 1 is still 10. And with a proportion, we know our cross products are equivalent or equal. So 1 times 3x minus 4 is 3x minus 4. And that should be equal to my other cross product, which is going to be 10 times 2x plus 3. So I get 10 times 2x plus 3. And if I distribute the 10 here, I get 3x minus 4 is equal to 20x plus 30. Now, what I'm going to do is I'm going to solve this equation for x. So I want to get the x terms on the same side of the equation. So I'll subtract 3x on both sides and add 30, no, subtract 30 rather. So now what happens is the 3x cancel. I'm left with negative 4 minus 30, which is negative 34. And the 30's cancel over here, and 20 minus 3 is 17x. 20x minus 3x is 17x. And so then to solve for x, I would divide both sides by 17. So 34 divided by 17, negative 34 rather divided by 17 is negative 2. So our solution is negative 2, but what this problem wants us to do is to check for extraneous solutions. So I need to go back into the original equation and plug in negative 2 to see if this is a fake or extra or what we call an extraneous solution. And so I'm going to go ahead back into the original equation and plug in negative 2 to see if the equation is true. Now, we came up with a solution of x equals negative 2, and I'm going to check in the original equation if this is a true statement if I plug in negative 2 for x. So I'm going to substitute negative 2 for x and see if this equation is true when I plug in negative 2 for x. So here over on the left side, I would get log of 3 times negative 2 is negative 6. Negative 6 minus 4 is negative 10 equals 1 plus log of, here we get negative 4 plus 3, which is negative 1. I already know that this is an extraneous solution because I cannot take the logarithm of a negative number. When I am taking a log of a number, my input has to be greater than 0. So log of 0, that's going to be an error, doesn't exist. And the same thing is true if I have a negative input when I am evaluating a logarithm. So I would say, like, for instance, log of negative 10, which we have up here, also doesn't exist. This is because exponential functions, when we raise a base to a power, our output or our y value is never less than 0, or equal to 0 for that matter as well. So this is why we cannot evaluate a logarithm for 0 or a negative number, because exponential functions are never negative or 0. And since the logarithmic functions are inverses of that, we would say that logarithms cannot be evaluated for 0 or negative numbers. So since negative 2 is not a solution, it's extraneous, we would say this problem has no solution. In example 8, guided practice, I would like you to solve log base 2 of x minus 6 is equal to 3 plus log base 2 of x minus 1. And your choices are A, B, C, and D. I would like you to go ahead and solve this logarithmic equation and check to see if your answer is extraneous, and then choose either A, B, C, or D as your solution. Once you have chosen your answer, then press submit.